Hello everybody and welcome to another mystery box function challenge. In the purple box there is some mystery math and your challenge is to figure out what that math is. You can use the link in the description, try out as many numbers as you like, and when you think you've got an answer, come on back and see if we get the same thing. All right, let's begin. I'm going to put in a 0. 0 gives us a -1. Okay, how about a 1? 0. How about a 2? 2 gives us 2, so that looks like a curve. It's not, going up by the same rate there between those two sets of points. So let's go in the negative direction. It's this -1.5, so the curve is continuing. How about -2? Now it's -1.75. Looks like it might be approaching that line. What if I go really far out, a -9? Still not quite at -2, but getting closer and closer. So I think we have an asymptote along y equals -2, and this is approaching as it goes out to -infinity here. I think I'm going to do a couple more points on the right, and then we're going to think about this. So I'm going to put in a 3. Okay, and a 4. All right, well, have you got some ideas about what this might be? Your first clue might be the shape. Maybe you recognize this shape. And what this shape looks like to me is an exponential function. So I think some number is being raised to the x power. And then something else has been done to this because it doesn't cross exactly where we'd expect it to cross. Anything to the 0 power is 1, and we got a -1 when we put in 0. So it doesn't quite fit with that, but maybe the graph has just been translated. Um, how can we tell what kind of exponential function this is? Well, even if you hadn't recognized the shape, one thing we could do is just start analyzing the numbers a little bit. And I think I'm going to take 0, 1, 2, 3, 4. Actually, let's just take 1, 2, 3, 4. We'll leave off 0 for now. So 0 for 1, I got a 0. For 2, I got a 2. For 3, 6, and for 4, 14. And to analyze these numbers, I'm going to look at the difference, how much they change. So from 0 to 2 is a change of 2. From 2 to 6 is a change of 4. And from 6 to 14 is a change of 8. 6 plus 8 is 14. Oftentimes, you'll take the differences and then take the difference of the differences. And if you get a constant, it would be a quadratic. In this case, we won't get a constant. This is always going to be doubling. If we did this again, 4 minus 2 is 2, 8 minus 4 is 4, we're going to have doubling every turn. When the amount that you're changing, the amount that you're increasing is doubling or going up by some other factor like that, tripling, quadrupling, etc., you know you have an exponential function. That's the pattern you see in the change between each step in an exponential function. In this case, because it's doubling, I know it's 2 to the x. So that's our base function. That's not the whole thing, but that's where we need to start. If this were tripling, it would be 3 to the x. If it were quadrupling, this would be 4 to the x. So what else do we need to do to this 2 to the x to just to make it match with our data here? And the point that always interests me with an exponential function is 0, because 2 to the 0 power, anything to the 0 power should equal 1. And what we got is a -1. So how would we get a -1 there? Well, we could subtract 2. So maybe this is 2 to the x minus 2. But let's check and see if that works with other points that we have on here. So let's put in a 2. So 2 to the second power minus 2, that would be 4 minus 2 equals 2. That's what we got. How about one of these negative numbers? So 2 to the -1 and minus 2. Well, 2 to the -1 is 1/2. I'm going to write that as 0.5. 0.5 minus 2 is 1.5. Sorry, -1.5. And that's exactly what we got. So I think this is just the graph of 2 to the x, just translated down 2 units by subtracting 2. So I think that's our function right there. And I'm going to go ahead and take a look at that. Yeah, we've got 2 to the x minus 2, and we can graph that as well. And you see that classic exponential function shooting up towards infinity really rapidly and approaching on the left, approaching that asymptote, in this case, the line y equals -2. Well, how did that go for you? Did you get that this was exponential? Let me know. Thanks, everybody.